Tonight we're going to spend some quiet hours with a man who changed the way every human being on Earth thinks about the universe. Not by arguing, not by conquering, not by accumulating great wealth or political power. He did it by sitting very still and thinking more carefully than almost anyone who had come before him, or since. Isaac Newton. The name is so familiar it barely registers anymore. Laws of motion, gravity, the apple. We say these things as if we've always known them, but we haven't. For most of human history, nobody knew. The planets wheeled overhead, and no one could say precisely why. Stones fell, and no one could prove mathematically what force was pulling them. The rainbow appeared in the sky after rain, and people had theories. Beautiful, ancient, completely wrong theories about what it was made of. The universe ran according to rules. Everybody sensed that. But the rules themselves were locked behind a door, and nobody had quite found the key. Newton found it, or most of it, in a country farmhouse, alone, during a plague. That's the story, roughly. But the actual story is stranger, more private, and far more human than that compressed version suggests, not the version people usually tell. Because Newton wasn't just a scientist. He was an alchemist who spent as much of his life chasing the philosopher's stone as he did working out orbital mechanics. He was a secret heretic who quietly disbelieved the central doctrine of Christianity at a time when that could end a career. Or worse. He was a man shaped by abandonment, who never married, who had almost no close friends, who could hold a grudge for decades with a patience and intensity that was almost geometric in its precision. He was also, without real dispute, one of the most intellectually powerful people who ever lived. So tonight, we'll move through the whole of it. The childhood that made him strange, the plague year that made him great, the book that rewrote the rules, the hidden rooms of his mind, the alchemy, the prophecy, the long obsession with ancient corruptions of sacred text, the breakdown, the slow and rather lonely end. Let's begin at the beginning. Section 2. Before he was born. Isaac Newton came into the world on Christmas Day 1642 in a small stone manor house in the hamlet of Woolsthorpe, in Lincolnshire, a flat, cold, agricultural part of England where the sky stretches wide and the winters are long. His father was also named Isaac Newton, a prosperous farmer. Not educated, could not, by some accounts, even sign his own name, but comfortably off. He died 3 months before his son was born. The baby never knew him, never had any memory of him at all. Just a name that was also his own name. Newton arrived prematurely. Small enough, his mother said, that he could have fit inside a quart mug, not expected to survive the first day, not expected to survive the first week. 2 women were reportedly sent to fetch medicine from a neighboring house and sat down on the way, not hurrying, because by the time they returned, they didn't expect the infant to still be breathing. He lived. He would live to be 84. His mother, Hannah Ayscough, was left alone in that Lincolnshire farmhouse with a fragile, fatherless boy and the business of managing an estate. She managed. And then, when Newton was about 3 years old, she remarried. A nearby minister named Barnabas Smith, a widower, well-to-do, considerably older than Hannah. Smith didn't want the boy. Hannah moved in with Smith. She left young Isaac with his grandmother in the manor house at Woolsthorpe. Not a visit, not a temporary arrangement. She simply left, and for most of the next decade, Newton grew up without her. We know this mattered because Newton himself told us, in a way. In his late teens, when he drew up a list of sins he had committed, he included this entry among the others: threatening my father and mother Smith to burn them and the house over them. And this is where things get strange, or rather, where they get very human. A child doesn't threaten to burn down a house, unless something in him is quietly raging. His grandmother raised him. We don't know much about her. She was kind by all appearances, or at least adequate. But we know from the texture of Newton's adult life, the extreme self-sufficiency, the difficulty with trust, the almost violent reaction whenever he felt criticized or robbed of credit, that something in that early rupture left a mark that never quite healed. He was essentially alone from the age of 3. He found ways to occupy that aloneness. Section 3. The Boy Who Built Things. At the King's School in Grantham, about 7 miles from Woolsthorpe, Newton lodged with an apothecary named Clark and distinguished himself primarily by building things: windmills, kites, water clocks, small mechanical devices of various kinds. He carved drawings into the walls of his room: birds, ships, mathematical figures, circles, triangles. One stylized windmill scratched into the stone at Woolsthorpe survives to this day. He watched a post mill being constructed near the school, and then built a working model of one, reportedly powered by a mouse on a treadmill. I find that detail genuinely wonderful. A mouse on a treadmill, running Newton's first machine. He was not, during these years, a conspicuously brilliant student in the conventional sense. He was absorbed in his own projects, conducted in his own mental world. There's a story, probably partly embellished by the time it reached biographers, that Newton's rise to the top of his class was sparked by a fight. A larger boy bullied him. Newton fought back and won. But winning the physical fight wasn't enough. He then beat the bully academically, moved himself up the rankings until he was first. Motivation, of a competitive and personal kind, was something Newton could tap when the situation demanded it. He simply preferred to direct it at the universe rather than other people. When Newton was nearly 17, Hannah pulled him from school to run the farm. He was hopeless at it. He ignored the cattle, let the pigs wander, sat under trees reading, or simply retreated into his own thinking. He built things and read books and let the farm largely look after itself, which farms do not do. 2 people saw past all of that: his schoolmaster, Henry Stokes, and his uncle, William Ayscough, who had himself studied at Cambridge. Both of them could see something in this odd, solitary young man that a livestock inventory would not reflect. They persuaded Hannah to send him back to school. She agreed. In June 1661, at the age of 18, Isaac Newton left Lincolnshire for the first time and arrived at Trinity College, Cambridge. Section 4. Cambridge, the strange student. He arrived as a sizar, a student who paid his way partly by doing domestic work for wealthier students and fellows, fetching things, running errands. Given the wealth of his widowed mother, this was likely a financial arrangement rather than pure necessity, but it placed Newton firmly below the social rank of most of his peers from the beginning. He was older than many of the other new arrivals, quieter. He had no obvious friends during his early years there. He bought a lock for his desk to keep his things private. He ate alone, often. He worked. Cambridge in 1661 was still teaching largely from Aristotle. The curriculum was traditional, medieval in some of its assumptions. Newton read it and then quietly went past it. He read Descartes. He read Galileo. He read Kepler. He obtained a copy of Euclid's Elements and reportedly found it too obvious, too elementary, and put it aside. He was doing something that students almost never do, following his own curiosity across the official curriculum, without regard for what would or would not appear on any examination. He kept a notebook, his questions he called it, in which he set down his own questions about the nature of matter, motion, space, and light. Not answers. Questions. In his third year, Cambridge elected him to a scholarship. Isaac Barrow, the Lucasian professor of mathematics, examined him and reportedly found his knowledge of Euclid deficient. He may not have noticed yet what he had. He would notice soon. Section 5. The Plague and the Miracle. Slightly more energy here. This is the pivot of the whole story. In the summer of 1665, the Great Plague reached Cambridge. London was already deep in it. A catastrophic outbreak that would kill roughly 1 in 5 Londoners before it was done. Cambridge closed its colleges and sent its students home. Newton went back to Woolsthorpe. He was 22 years old. He had a degree, no particular distinction, and no obvious promise that the wider world could see. He had a room in his mother's farmhouse, a view of the orchard, and, for the better part of 18 months, essentially nothing to do. And this is where things get strange. What happened in those 18 months is one of the most remarkable episodes in the history of human thought. He worked on calculus. He developed the binomial theorem. He conducted his first sustained experiments on light using a prism purchased at a fair. He worked out the mathematical basis of what we now call gravity, and connected the force that pulls objects to the Earth with the force that keeps the Moon in its orbit. Years later, Newton himself described this period matter-of-factly. In those days, I was in the prime of my age for invention, and minded mathematics and philosophy more than at any time since. He was not being modest. He was being accurate. The calculus alone would have been enough to secure his place in history. No such mathematical tool existed before him. No formal method for calculating rates of change, areas under curves, the behavior of quantities that vary continuously rather than in discrete jumps. The physical world, as it turns out, moves continuously. To describe that mathematically, you need calculus. Newton invented it, not in a flash, across months of sustained private work, alone at a farmhouse in Lincolnshire. The apple story. It's worth pausing on. Newton did tell the story himself, in old age. He said that the sight of an apple falling in the orchard prompted the chain of thought that eventually led him to formulate universal gravitation. Did it hit him on the head? That version seems to have been invented by Isaac D'Israeli, the father of the British Prime Minister, sometime in the early 1800s. The actual story is quieter and more interesting than a piece of falling fruit striking a skull. He saw the apple fall, and he asked a question that people had not seriously asked before, at least not with the mathematical tools to answer it. Why does it fall straight down? What force produces that fall? And if a force reaches from the earth all the way to the top of a tree, does it reach further? Does it reach all the way to the moon? The answer was yes. But proving it rigorously took another 20 years. Section 6. Light in a dark room. Newton returned to Cambridge in 1667 and was elected a Fellow of Trinity. A year later, he had his master's degree. In 1669, Isaac Barrow, recognizing what he now had in front of him, resigned his Lucasian professorship and recommended Newton as his successor. Newton was 26 years old when he became one of the most prestigious mathematics professors in England. He spent the next few years working on optics. He darkened his room, made a small hole in the shutter to admit a single beam of sunlight, and held a glass prism in its path. This was not a novel thing to do. People had been sending light through prisms for years. They knew that prisms produced colored rainbows. The question was what this meant. The prevailing explanation, going back centuries, was that the prism was corrupting or modifying the light, introducing color where previously there was only pure white. Newton thought that was wrong. He thought the colors were already in the light, that white light was not simple but composite, a mixture of all colors traveling together. The prism didn't create the colors. It separated them. Because each color has its own angle of refraction, its own degree to which it bends passing through glass. To test this, he passed one of the separated colors through a second prism. If the prism were corrupting light, the second prism should change the red. It didn't. Red went in, red came out. The color was fixed and stable, inherent in the ray itself, not imposed by the glass. He coined the word spectrum to describe the band of colors. He showed that the colors could be recombined, passing them through a second prism in the opposite orientation, to produce white light again. White light is not the simplest thing. It's the most complex, the sum of all the visible colors at once. This was not a minor finding. It was a complete reversal of 2,000 years of thinking about light. Color is not something added to light. Color is what light is made of. He sent a paper on this to the Royal Society in 1672, his first scientific publication. The reception was not what he might have hoped. Robert Hooke, an enormously capable experimental philosopher, criticized it sharply. Newton did not respond well to criticism, ever. He told the Royal Society he wanted to be freed from correspondence about his optical discoveries. He essentially went silent. He would nurse that fury for decades. Section 7. The Reflecting Telescope and the Royal Society. While the optics controversy was still fresh, Newton had built something remarkable, the first reflecting telescope. Previous telescopes used lenses. Lenses refract light, and because different colors refract at slightly different angles, they produce blurry chromatic fringes around whatever you're looking at. Newton's solution was to replace the lens with a mirror. Mirrors reflect all colors equally. No chromatic aberration. He built one by hand, grinding and polishing the mirror himself. A compact instrument, about 6 inches long, that performed better than much longer refracting telescopes of the period. He brought it to London. The Royal Society was impressed enough to elect him a Fellow in 1672. He was 29. And then he went back to his rooms and kept working, quietly, still on things he hadn't shown anyone. Cambridge was a kind of isolation tank for him. He didn't particularly like teaching. His lectures were reportedly so advanced that students often didn't attend, and he gave them whether anyone came or not, sometimes to an empty room. I find that image haunting, honestly. The greatest mind of the age, lecturing to an empty hall. Not because no one cared, but because no one could follow. He seemed to prefer privacy. He needed to be certain before he showed anything. Not reasonably certain. Completely certain. He would sit on a discovery for years, sometimes decades. Not because he was lazy or distracted. Because he was still working, still testing, still trying to find the place where the chain of logic might have a weak link. He couldn't bear to put something into the world and have it come back damaged by a valid objection. He was also, by this point, spending a significant amount of time on alchemy. Section 8. The Alchemist. Calm, slightly wondering. This is strange and fascinating territory. This is the part of Newton's story that people often find uncomfortable or just puzzling. He owned more alchemical texts than scientific ones. He built furnaces in his rooms at Cambridge and conducted chemical experiments, 108 of them involving metals alone, by the count in his notebooks. He tasted metals. He recorded the tastes. He corresponded with other alchemists under assumed names. This is not as bizarre as it sounds, if you think about when Newton was alive. The line between natural philosophy and what we now call alchemy or mysticism was not sharp and obvious in the 17th century. It was porous, contested, often invisible. Newton believed the universe was a text, that God had left messages in two kinds of writing: in nature itself, which could be read through mathematics and experiment, and in scripture, which could be read if you deciphered its layers of symbolic meaning. He did not think these were two separate projects. He thought they were one project. John Maynard Keynes, the economist, bought a large cache of Newton's private manuscripts at auction in 1936. After reading them, he called Newton the last of the magicians. He meant it as an honest description, not as mockery. Newton's mind, Keynes argued, operated by some extraordinary power of concentration that allowed him to hold a problem whole and turn it over until he saw the answer. What was he actually looking for in those furnace-lit rooms? The philosopher's stone formally. But that was the outer layer of the question. The deeper thing Newton was after was what he called the secret fire. An animating principle that he believed existed throughout nature. A subtle spirit, not quite material, not quite immaterial, that was responsible for the active, living quality of the world. He never found it. The alchemical notebooks record experiments with antimony, lead, mercury, sulfur, gold, iron, tin. They record processes with evocative names: the peacock's tail, the green lion, the philosophical mercury. They record results without obvious pattern. He never published any of this. He kept it almost entirely secret. The notebooks were packed away, not burned, but hidden. Section 9. A comet, a question and a visit. Energy picks up slightly here. This is the build-up to the Principia. By 1680, Newton was in his late 30s. He had done the work of several lifetimes already, most of it unpublished, most of it known to no one. A comet appeared in the winter of 1680, visible across Europe. Newton began corresponding with the royal astronomer about its path. A second comet appeared in 1681. Newton eventually concluded, correctly, that these were the same comet, observed on its way in and on its way back out, having swung around the sun. He didn't publish anything. In 1684, a young astronomer named Edmund Halley visited Newton at Cambridge. Halley was trying to solve a specific problem. Could the elliptical orbits of the planets be explained mathematically by an inverse square law of gravitational attraction? He had discussed it with Robert Hooke and Christopher Wren. Nobody had been able to prove it. He asked Newton, Newton said he had. He had solved this problem. More than that, he had worked it all out, years earlier, during the plague. He began looking for his notes. He couldn't find them. He told Halley he would rework the proof and send it. He sent a short paper, 9 pages, a few months later. Halley read it and immediately understood that what Newton had sent him was not a brief proof. It was the outline of a complete new mechanics, a comprehensive mathematical description of how everything in the universe moves. He went back to Cambridge. He urged Newton to expand it. He offered to pay for its publication himself. Newton agreed, and then spent the next 2.5 years writing one of the greatest scientific books ever produced. Section 10. The Principia. This is the key moment, allow it to land. He called it Philosophia Naturalis Principia Mathematica, the mathematical principles of natural philosophy. It was published in July 1687. Halley paid for it out of his own pocket, because the Royal Society had spent its publication budget on a book about fish. The Principia contained Newton's 3 laws of motion. The first, a body at rest stays at rest, and a body in motion stays in motion in a straight line, unless acted upon by an external force. The second, the force acting on a body equals its mass times its acceleration. The third, for every action there is an equal and opposite reaction. 3 sentences. Engineers still use them today. Every time something has to be moved from one place to another. And then there was the law of universal gravitation. Every mass in the universe attracts every other mass, with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. Not just apples and planets. Everything, every particle of matter that has ever existed, exerts a gravitational pull on every other particle of matter that has ever existed. The force diminishes with distance, but it never reaches zero. A stone on a table is attracting the moon, imperceptibly, but genuinely. For 2,000 years, most scientific thinking had kept the terrestrial and the celestial separate. Earth was one kind of place. The heavens were another. Newton erased that distinction with a single mathematical equation. When asked what gravity actually was, what substance or process communicated it, he famously refused to speculate. "I feign no hypotheses," he wrote. He would describe the behavior. He would not invent an explanation for what he could not measure. I find that kind of intellectual honesty rare, even now. Section 11. Fame and its complications. Fame suited Newton badly. He had spent his career working alone, thinking alone, keeping his discoveries private until he was absolutely certain about them. Now all of that came at him whether he wanted it or not. He represented Cambridge briefly in Parliament in 1689 and 1690. The only recorded speech he ever made during those sessions was a request to close a window. He became close during this period to 2 people. One was John Locke, the philosopher. The other was Nicolas Fatio de Duillier, a young Swiss mathematician, who Newton apparently found genuinely engaging. Rare for him. Their correspondence was warm, occasionally intimate in tone. It may have been the closest relationship Newton ever had with another adult. It ended in 1693, suddenly, without a clear explanation in the historical record. Fatio wrote a letter, and Newton's response was cold, distant, almost formally polite in that way that communicates the opposite of politeness. Whatever had been between them was over. Shortly afterward, Newton wrote strange, irrational letters to Samuel Pepys and John Locke. He accused them of trying to embroil him with women. He said he wanted to see neither of them anymore. He wrote that he had been unable to eat or sleep for several days. He was having a breakdown. The cause is genuinely uncertain. Some historians attribute it primarily to the end of the relationship with Fatio. Others point to the sheer intensity of sustained intellectual work over decades. The most physically specific explanation, supported by analysis of hair samples taken from Newton's body after his death, is mercury poisoning. His hair contained levels of mercury 15 times the normal range. Lead and arsenic were also elevated. He had been handling these substances in his alchemical experiments for years, sometimes tasting them directly, working in poorly ventilated rooms. He recovered. But his career as an original scientist was essentially over. He was 50 years old. He had done more than almost anyone else who has ever lived, and he had done most of it before 40. Section 12. The Master of the Mint. In 1696, Newton left Cambridge. He had spent 35 years there. He moved to London and was appointed Warden of the Royal Mint. This was not a sinecure. England's coinage was in crisis. The silver coins in circulation had been progressively clipped, people shaving metal from their edges and pocketing the silver, until many of the coins circulating were significantly lighter than their face value. Newton threw himself into this with the same intensity he had brought to mathematics. He reorganized the operations of the mint, increased output dramatically, and brought to the quality of the new coins, in his own words, a degree of exactness never previously achieved. He was also, perhaps surprisingly, a relentless pursuer of counterfeiters. Counterfeiting was a capital offense. Men convicted were hanged and quartered. Newton knew this, hated the punishments, and pursued counterfeiters anyway. He went in disguise to taverns and jails. He cross-examined informants personally. He gathered evidence with the methodical thoroughness of a man who understood systems and how to break them. There was something in this work that genuinely suited him. He was used to tracking invisible things, the hidden rules of nature, the secret corruptions of Scripture. Counterfeiting was, in a way, the same kind of problem. A false thing masquerading as a true thing. Newton had spent his whole career finding those corruptions and exposing them. He was very good at it. The most famous of his targets was William Chaloner, a forger of considerable audacity, who had the additional nerve to petition Parliament, claiming that the mint was poorly run and that he, Chaloner, could improve it. Newton investigated him with cold patience over several years, built a case piece by piece, and ultimately had Chaloner hanged at Tyburn in 1699. He made no public comment about it. He moved on to the next case. Section 13. The Secret Theology. Slow and thoughtful, this is the most hidden, private part of the story. All through this period, all through Cambridge, through the writing of the Principia, through the years at the Mint, Newton was carrying on a second intellectual life, that almost no one knew about. He was writing theology, not orthodox theology, dangerous theology. He had concluded through careful study of early Christian writings and the Bible in its original languages that the doctrine of the Trinity, the belief that God the Father, Jesus Christ, and the Holy Spirit are three persons in one God, was a corruption, a fraud inserted into Christianity by scheming 4th century bishops. Newton was, in other words, a heretic. In Newton's day, heresy of this kind could cost you your position, your freedom, and potentially your life. He kept it almost entirely secret. He wrote millions of words on theological subjects. This is not an exaggeration. When his private papers were eventually examined and catalogued, the theological and historical writings came to more pages than the scientific ones. Not the version people usually tell about Isaac Newton. His private papers went into trunks after his death. They stayed in those trunks, mostly unread, for over 2 centuries. When they came to auction in 1936, the scientific establishment largely didn't want them. Keynes bought many of them. A Jewish scholar named Abraham Yehuda bought many of the theological ones, and eventually donated them to the Hebrew University. The man who had devoted decades of his life to proving that Christianity had been corrupted ended up with his private papers in the library of a Hebrew university, in the land his own writings had touched on as a prophesied Jewish restoration. History has a sense of irony that it rarely bothers to explain. Section 14. The President. In 1703, Newton was elected President of the Royal Society. He was re-elected every year until his death. 24 years as President. In 1704, he finally published Optics, his account of his work on light and color, written this time in English rather than Latin, in a more accessible style. It appeared 30 years after he had done most of the work it described. He had waited for Hooke to die before publishing it. Hooke died in 1703. Newton published in 1704. In 1705, Queen Anne knighted him. He became Sir Isaac Newton. That same year, the dispute with Leibniz over the invention of calculus moved into open warfare. Both of them had invented calculus independently. This is the conclusion of most historians of mathematics, and it is almost certainly correct. Newton could not accept this. He used his position as President of the Royal Society to establish a committee to investigate the priority question. He wrote the committee's report himself, anonymously. He then wrote an anonymous review of the report. He was judge, jury, and anonymous witness all at once. The dispute poisoned the last decades of both men's lives. Leibniz died in 1716, feeling humiliated and robbed of credit. Newton outlived him by 11 years. Section 15. The Private Man. Slow, intimate, reflective. Newton never married. He had, as far as anyone can tell, no romantic relationships with anyone, no interest in pursuit of that kind. He lived modestly. He ate simply, often forgetting meals during periods of intense work. His niece Catherine Barton kept house for him in London for many years. She was beautiful and sharp-witted, well known in London social circles. And Newton was fond of her in the way that a very private man is fond of someone, who manages the world for him without demanding entry into the parts he keeps locked. He was solitary in a way that seems to have been entirely natural to him, rather than sad. He had learned, very early, to be complete in himself. He had never had the experience of being held by someone who would stay. What others might have put into relationships, he put into thinking. There is one thing he said in old age that has stayed with people. He said, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself now and then in finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." This has sometimes been read as false modesty. It isn't. Newton was not a modest man in competitive situations, but this was not about competition. This was a genuine recognition that the universe he had spent his life trying to describe was far larger and stranger than anything he had managed to capture. The laws he had found, real and powerful as they were still only the visible shallows. The ocean went on. He knew it went on. He had looked out at it his whole life. Section 16. The Ending. Gentle, slow, winding down toward sleep. In the winter of 1725, at the age of 82, Newton's health began declining. He had kidney stones. He experienced increasing pain. He moved to Kensington, just outside London, for the air. He continued going to the Mint when he could. He continued attending Royal Society meetings. He revised his major works. He worked on his theological writings. In his final weeks, by some accounts, he was still working obsessively on an alternative history of the ancient world, trying to reconcile ancient Greek mythology with biblical chronology. On the 18th of March, 1727, he became delirious. He stayed that way for 2 days. Early in the morning of March 20th, between 1 and 2 in the morning, he died. He was 84 years old. He had refused, near the end, the last rites of the Church of England. The man who privately considered the Church's central doctrine a fraud did not wish to perform that particular act of hypocrisy at the very end. He was buried in Westminster Abbey on April 4, 1727, the first scientist to be so honoured. Voltaire, visiting London from France, was apparently present at the burial. He returned to France deeply impressed by a country that honoured its scientists like other countries honoured their kings. The pallbearers at Newton's funeral included dukes and earls. He had left no children. He left an estate divided among his niece and other relatives. He left his books, his instruments, his private papers. He left, above all, a way of understanding the world that would not be seriously challenged until Einstein published his general theory of relativity in 1915, more than 2 centuries later. Einstein's general relativity doesn't actually disprove Newton. It replaces him at the extremes, at very large scales and very high velocities, where the geometry of space-time begins to bend in ways Newton's mechanics doesn't account for. But in the realm of ordinary experience, in the world where engineers design bridges and astronomers track comets, Newton is still the operating system. The Apollo missions to the Moon were calculated using Newtonian mechanics. The Voyager spacecraft, launched in 1977 and now in interstellar space, traveled along trajectories computed from Newton's laws. Calculus. It is hard to overstate what calculus made possible. It is the mathematical language of change. Every equation in physics that involves anything that varies over time. The trajectory of a rocket, the oscillation of a current, the evolution of a star, is written in calculus. Newton and Leibniz, between them, gave the world this tool. The laws of motion, the law of universal gravitation, the mathematical foundation of calculus, the demonstration that white light is composite, the reflecting telescope. Any one of these would be enough to secure a place in history. Newton produced all of them. The question of how any of this is possible, how one person could contain all of it, doesn't have a satisfying answer. Exceptional intellect, obviously, an almost pathological capacity for sustained concentration. A childhood that isolated him and forced him into his own resources at a very early age. the plague that sent him home from Cambridge at exactly the right moment. And something harder to name, something in the way he looked at problems, holding them whole, refusing to release them, turning them over in the dark of his room through the night, until the answer appeared. Not intuition exactly, not calculation exactly, some third thing that combined them in a way that very few people in history have managed. He believed until the end of his life that the universe was a code, that God had embedded its laws in the structure of matter and the words of Scripture, and that a sufficiently prepared and sufficiently patient human mind could read that code and understand the whole. He got closer than anyone before him. He knew he hadn't gotten to the end of it. The ocean of truth, he said, still undiscovered. He left us standing at the shore with better tools than he found, looking out at the same vast water. Section 18, Closing Thought. The slowest section, almost a lullaby pace. It's worth sitting for a moment, with what Newton's life actually looked like from the inside. Not the legend, not the textbook. A premature baby left in a farmhouse, by a mother who remarried and moved away. A boy who threatened to burn down his stepfather's house. A student who was not particularly distinguished in the conventional sense, spending his free hours building windmills and reading past the curriculum. A young man sent home by plague, who sat alone in Lincolnshire for 18 months and quietly rewrote the rules of the universe. A man who spent as much of his life searching for the philosopher's stone as he did working out celestial mechanics. A man who filled millions of words in private notebooks with arguments that the Trinity was a lie, and who kept all of it hidden because the age he lived in would not have understood and might have punished him for it. A man who had one close friendship in adulthood, who lost it under unclear circumstances, and who had what appears to have been a complete mental collapse, possibly caused, at least in part, by the mercury he had been tasting in his alchemical experiments. A man who then went to London, ran the mint, chased counterfeiters in disguise, reorganized the English currency, led the Royal Society for 24 years, published books he had been sitting on for decades, and waged a bitter public war over mathematical priority until the other man in the dispute was dead. And then declined slowly, still working, still revising, still arguing in private notebooks with early church fathers who had been dead for 14 centuries. The great ocean of truth, still undiscovered. He played on its shore his whole life, and what he found there, the smoother pebbles, the prettier shells, changed the world so completely that we have no memory of what the shore looked like before he walked it. Tonight, as the world around you settles into quiet and your thoughts begin to grow soft and slow, consider that the rules you live inside, the physics of every object in every room, the invisible force that holds you to the earth, the spectrum of color in every beam of light that has ever reached your eyes, were for most of human history unknown, locked, waiting. A small solitary boy in a Lincolnshire farmhouse found the key. Sleep well. And if tonight's quiet journey through Newton's life has given you something to carry into your rest, if you've liked what you found here, consider leaving a like and subscribing to the Sleepy Biographer. Every story we tell helps another restless mind find its way to stillness. One night, one life, one quiet hour at a time. Good night.